Hello, and welcome to this lesson on graphs. That's the topic for this week. We are going to learn a little bit this lesson, and then next lesson I will post on some exam questions for you to have a go at with some mark schemes. Yeah, anyway, excuse me. This is all about how we show data. As well as graphs, you need to know about summary tables. Summary tables are very useful to help us interpret data. If you're asked to draw a summary table in an exam, they will give you the data, and it will be descriptive statistics, like, for example, the mean and the standard deviation. Not raw data. We don't use summary tables for raw data. They always go in the appendix when you do a study. In the actual report itself, you would use a summary table just showing your main descriptive statistics. It would always come with a summary paragraph to explain what the table shows. So, for example, in this case, the table is about an experiment showing the mean number of words spoken in 5 minutes when consuming an energy drink or water. And you can see on average the group managed 96 words in 5 minutes with water and 119 with the energy drink. The summary paragraph would then state that this suggests consuming energy drinks speeds up the amount you talk. The standard deviation suggests there's slightly more variance in the water condition than there is in the energy drink condition. So in the water condition, they were slightly more clustered around the mean. That's that one. And it's important with any summary table that you have a title and that the title explains what is in the table. So if you're asked to draw a table at any point, just make sure that you include a detailed title to show what the table shows. Table's pretty self-explanatory, don't really need to bang on about that too much. The other thing you might be asked to do when analysing data would be to draw a graph. We'll talk a little bit more about what else you might have to do with graphs in a sec, but when drawing graphs, you have to bear in mind the following things for your exam. To get full marks, you need to make sure that both axes are clearly labelled, okay? So that's the X and the Y axes. That you plot bars or points, depending on what kind of graph you're drawing, correctly. That it includes a detailed title. Always put a title, and the title has to be detailed enough, in other words, contain all the information that anyone would need to be able to interpret the graph. So not just, a graph showing stuff. It has to sort of say what the study was about, and that the scales that you choose are appropriate. This can be the tricky one, really. Some graphs require that you have to start at 0 on a scale, others don't. So whatever scale you choose has got to be appropriate so you can actually see a difference maybe in the height of the bars or the plotting of the points. Okay, so there are 4 main types of graph that you need to know, and 2 of which you might need to draw. One of the ones that you might need to draw itself is a bar chart. Bar chart's pretty self-explanatory. Come on, it's probably the first graph every single one of you drew. Bar charts, you see, here's an example. Oh, look at the detail in the title there. Experienced depressive illness before having children, with information about the sample. Bar charts are particularly useful for showing nominal data. That's data in categories. You know that from last lesson. So here we've got depression, bipolar, self-diagnosed, treated. So these are categories. And then the percentage of mothers who had experienced depression. Bar charts always have gaps of an equal width apart, and that's because the data is not continuous. It doesn't actually matter which order these go in. They're not actually related to each other. So in that sense, because it's not what we would call continuous data, we always have to have a gap in between the bars. The height of the bars should be accurate enough so you can work it out, and that indicates the frequency. So if this was showing preferences for soft drinks or whatever, up here you'd have the, rather than the percentage, you'd have the mode, and you'd have like 8 people like Coke. So in a bar chart, it's very important that the bars don't touch each other, and that's because that would indicate it's a different sort of graph, which we'll come on to a second. You can use clustered bar charts to show more than one sample of data. So this is where, so for in this, people have attended a particular session, did they or didn't they, yes, no. So you've got 2 bars for each group, and the gap falls, so you've got group A here, this many yes, this many no, gap group B, gap group C. So you can cluster the bars together because these are actually now related to each other, but D is not related to C or B or A. So it's very, very important, as I say, that the bars touch each other, because if they do, then they become a histogram. A histogram looks like the bar chart, but the bars touch. Okay, there are tiny gaps here, but you see what I mean. Histograms are used to show continuous data. So you can see a sort of spread over, this is a continuous scale. Actually, this graph here, fun fact, is the results of the descriptive statistics test I set you last week. And it tells you this many students got 19, this many students got 20, 21, 22, so on and so forth. And what histograms are particularly useful for is showing continuous data. So obviously 20 comes after 19 and before 21. This is a continuous scale. So in this sense, we would put the bars next to each other, and that becomes a histogram. It does now matter where these bars go. Do you see what I mean about the bar chart? It doesn't actually matter which bar you draw first, whereas in a histogram it does matter that 19 goes before 20. The bars should be equal width, because the area of the bar should be proportional to the frequency represented. So if you draw one thicker than the other, that would indicate somehow that there's more in that category, and we want to avoid that, so make sure you draw them all equal width. Because it's continuous data, the vertical axes must start at 0. On a bar chart, you can actually start it, if no one has got less than 10, you could start the bar at 10 down here. But on a histogram and all the other kinds of graph, you must have an absolute 0. And because we're using ordinal and interval data, that's why, particularly with the interval data, it's very important that we have a 0. So that's histograms, very much like bar charts to look at, but the lack of gaps is the clue. Line graphs, you might see, you won't be asked to draw histograms or line graphs, but a line graph is basically like a histogram, but instead of drawing bars, you just put dots at the top of where each bar would go. This is particularly useful if the bars would be too close together, and you join them up with a line. But effectively, it's showing the same sort of information. Histograms are particularly useful if you're plotting more than one data set on top of each other. So here we've got 2010, 2019, 90. That would look really confusing if it was drawn as a histogram. So we draw it as a line graph. Again, line graphs very good for interval and ratio data. Line graphs can drop below 0 if you're doing interval. They don't there. And then we've got scattergrams. Now, scattergrams you should all be familiar with from when we did correlations, because scattergrams show correlations. So they show a relationship between 2 variables. So on one axis you have one variable, on the other axis you have another variable, and each plot of data represents one data point. So here we've got teacher ratings of aggressiveness in children, and then the hours of TV they watch. So this little dot here represents one child, and this child got a rating, an aggression rating of 7, and watched 7 hours of TV a day. So obviously scattergrams are useful because you can draw a line of best fit, and if it goes like that, then you know you've got a positive correlation. If it goes like that, then you know you've got a negative correlation. If they're all over the shop, you know that there is no correlation. Scattergrams are also useful because you can spot anomalies in your data set quite easily. This child here, this placid little fella, I'm assuming he's a male, gets a rating of 1. Not very aggressive at all, but watches 9 hours of TV a day. So he's not really fitting the pattern. So scattergrams are a graph that you might be asked to draw. So it's important with those 4 types of graph that you know why you would use them. Mainly for the purposes of the exam, if it's nominal data, you're going to use a bar chart. If the data is showing a continuous relationship, you'd use a histogram or line. And if it's a correlation, you're going to use a scattergram. In terms of the graph, you are likely to be asked how to interpret them, so that would be read data off them, and that includes pie charts. Now I set you an example of that last lesson. So you might be given a pie chart or a graph and you're asked to tell me how many kids did X, Y, Z, whatever the graph's showing. Yeah, so that's a very straightforward question. Can you read a graph? You might be asked to draw them. This is likely to be a bar chart or a scattergram. Here they would give you the raw data and they would give you a piece of graph paper on your exam paper and ask you to draw one. And so we're going to have a little go at that. So in this activity, you're going to need a bit of paper to sketch out a scattergram. Now, obviously, I am not going to be checking this. I don't want you to take a picture of it and send it to me, but I want you to pause the video in a second and have a go. Once I show you the data set, have a go at drawing a scattergram and labeling the axes. So this is the reason for it. Each participant was asked to take part in a discussion of social care issues. This included a discussion about who should pay for social care of the elderly and how to deal with people struggling with mental health problems. A confederate of the researchers was given a script to follow in which a series of discussion points was written for the confederate to introduce. So we know a confederate is someone paid by the researcher, a stooge. The researchers observed the discussions between the confederate and the participants and rated the active engagement of the participants in the discussion. The ratings were between 1, showing not at all interested, and 20, extremely interested. The researchers believed that the rating provides the measurement of the participants' attitudes towards social care issues. So the higher the rating, like if they got a 20, wow, they must be really interested in social care. If they're 1, oh, they don't care about old people. So this would be an example of ordinal data being used. Okay, so here is the data. You've got the age of the participants going down on one axis, ranging from 21 to 60, and then their attitudes towards social care. So we're looking to see if there is a relationship between the age of the participants in the study and whether or not they care about old people. So I'd like you to grab a piece of paper, pause the video, try and draw a scattergram to show that information. Okay, assuming that you've done that, and you did pause it and all of that sort of stuff, you will get, on this kind of question in the exam, you would get 3 marks if you labelled the axes correctly. One axis should be labelled age of participant, the other one attitude towards social care rating. They were the titles on the raw data. That you've used suitable scales, i.e. they go up enough to cover all of the numbers, and that you plot each bit accurately. If you've done that, you should end up with a scatter graph that either looks like this. So this assumes that you've put this on the right axis, attitudes towards social care on that side, age. I'll show you what it would look like if you swap those two over in a second. But as you can see, it's a positive correlation, and it would look something like that if you put them that way, or that if you put them the other way around. Still a positive correlation, so that's all right then. Doesn't actually matter which way you put them round. And there you go. So that's the kind of thing you might be asked to do in an exam. I'm going to post some more exam questions next lesson that involve practicing drawing graphs, but also some other research methods-y type stuff, so you can have a go at that. I'll also post mark schemes so you can check your answers, and I will be on hand next lesson to answer any questions that you have about the graphs in this lesson or the exam questions. Okay, right, well, thanks for listening. See you later. Bye.